Winter 1943. On the approaches to the Gustav Line south of Rome. A German machine gun crew has prepared their position according to the doctrine they learned in training and refined in combat. The MG-42 sits on a reverse slope, set back from the crest of the ridge, invisible from the valley below. 200 meters of cleared ground falls away in front of it, every meter ranged, every approach angle covered. The position to the left holds the gap their arc can't reach. Between them, nothing moves on that hillside without crossing a kill zone. The crew has done everything correctly. Their position is impenetrable to direct fire from any angle they can be approached from. The British section working up the slope can neither see them nor range them with rifle fire. The section's Bren gun has been firing for 3 minutes on the ridgeline crest, not the position behind it. The noise is enormous, the effectiveness is zero. Then a bomb arrives from nearly straight overhead. It was fired 200 meters away by 2 men who had never stopped moving, with the section pressing up the slope. A small steel baseplate resting on the cold ground. A 21-inch tube held at an angle by one soldier's hands, aimed by eye and instinct, fired by a trigger squeeze from his partner. The complete apparatus, tube, baseplate, trigger mechanism, weighed 10.5 pounds. Light enough that when the section moved, the 2 men carrying it moved with them, not behind them. The Ordnance SBML 2-inch mortar was standard issue to every British infantry platoon from 1938 through the end of the war. By conventional technical assessment, it was the crudest weapon in the platoon's arsenal. British soldiers who looked at it and saw something that resembled domestic drain pipe weren't entirely wrong about the appearance. They were entirely wrong about the implications. German soldiers at the Gustav Line, the Winter Line, and the Gothic Line came to understand the difference. Every specification the 2-inch mortar carried seemed designed to invite dismissal. Caliber, 51.25 millimeters. Length, 21 inches. Weight, 10.5 pounds. No bipod. As the war progressed and field experience accumulated, the early rudimentary sights were removed as unnecessary. The airborne variant of 1942 to 1945 had them stripped formally, and the standard infantry version followed. What replaced optical aiming was the operator's own body. One hand cupping the tube at the correct elevation angle, adjusted between rounds, calibrated by repetition rather than by any instrument. A veteran from the mortar platoon of the 2nd Durham Light Infantry, interviewed decades after the war, still remembered the exact physical technique for operating it. That kind of retained muscle memory speaks to how completely manual the process was. The mortar became an extension of the body carrying it. The trigger mechanism is the telling mechanical detail. Every other mortar in British service used the standard drop-fire principle. The bomb slides down the muzzle, the propellant charge in the bomb's tail strikes a fixed firing pin at the base of the tube, and the round launches. It works because the bomb travels far enough down the tube to build the velocity required for reliable detonation. The 2-inch barrel, at 21 inches, was too short. A bomb dropped into it didn't travel far enough to generate sufficient impact force at the base. The engineer's solution was a trip mechanism at the breech. The bomb is held at the muzzle by the loader. The firer squeezes a trigger which drives the firing pin mechanically into the propellant charge. The bomb launches. Because the 21-inch barrel was too short for a drop-fire mechanism to build sufficient velocity, engineers had to design a separate trigger mechanism at the breech to initiate the firing sequence. That mechanism existed as the price paid for a specific size and weight target, a weapon small enough to carry into a firefight by the men already fighting it, light enough not to require a dedicated vehicle or a separate carrying party, compact enough to set up and fire in the seconds between one burst of contact fire and the next. Short barrel, small propellant charge, mechanical trigger to compensate. Every element pointing toward the same goal. The weight difference tells the rest of the story. The 3-inch mortar, the battalion-level weapon that provided heavier indirect fire support, weighed 115 pounds in total, broken into 3 separately carried loads. Carried on 3 men's backs or loaded into universal carriers. Setup time was measured in minutes. The formal request process required to bring it to bear on a target ran through company and battalion command chains. A section commander with his men already in the open couldn't stop the firefight to make a radio request and then wait. The 3-inch mortar wasn't, at that moment, available to him. The 2-inch mortar was 10.5 pounds. The lance corporal commanding the detachment and his 2 operators moved with the platoon. They carried the tube, the baseplate, and the ammunition into the advance. There was no setup delay that mattered tactically. There was no request chain to navigate. When the section commander needed overhead fire, he had it within the time it took 2 men to unsling the weapon and rest the baseplate on the ground. 3 types of bomb: high explosive for destruction of positions, smoke for concealment of movement, and illuminating for night operations. Sustained rate of fire of 8 rounds per minute. Range to approximately 500 yards. Elevation from 45 to 90 degrees. The steep arc that wasn't a limitation of the design, but its entire tactical point. The doctrine was specific about what the weapon was for. Each British rifle platoon of the 1943 to 1945 establishment was built around 3 10-man rifle sections and a platoon headquarters. That headquarters included the 2-inch mortar detachment, a lance corporal in command with 2 operators for the weapon. The platoon commander owned the mortar as a direct asset. He didn't request its use through the chain. He directed it in real time at whatever problem his platoon faced. British military doctrine describes this arrangement as organic indirect fire. Indirect fire capability that belongs to and moves with the unit using it, rather than being allocated from a centralized support pool in response to a formal request. The distinction matters enormously in practice. To reach a target with the battalion's 3-inch mortars required a request that climbed from section to platoon to company to battalion fire control, each step adding delay. In Italy, on a mountainside, in contact with an enemy machine gun position, that delay couldn't be filled with anything except casualties. Wartime establishment documents confirm that the 2-inch mortar could be employed immediately by the platoon commander, without requesting support from company or battalion. That word, immediately, defines the weapon's operational identity more precisely than its caliber or range. Not its weight, not its accuracy. Its availability in the first seconds of an engagement, before any other support had been asked for or was on the way. Formal doctrine designated the weapon primarily as the platoon commander's smoke and light-producing weapon, a tool for blinding machine gun positions long enough for a section to close the distance, covering withdrawals under fire, screening assaults across open ground. Smoke was the doctrinal priority. High explosive was the secondary designation. In Italy, the high explosive role frequently became primary. A platoon attacking up a slope toward a position, firing from behind a crest, had neither the time nor the capability to call for anything else. The weapon had been proving itself before Italy. From June 1940, when British forces opened operations in North Africa, the 2-inch mortar deployed as a standard platoon asset. Indian army establishments in the Western Desert listed 1 2-inch mortar per platoon, alongside the 6 3-inch mortars held at battalion level. The same organic structure that would define British infantry doctrine through 1945. In the open terrain of the Libyan and Egyptian deserts, mortar and machine gun fire, British and German both, were established as the two most feared weapons in that theatre. The plunging arc worked in the desert as it would work in the mountains, overhead, against positions that lay behind whatever cover the terrain provided. North Africa proved the concept against a professional enemy in sustained combat. The Italian mountains would prove it against deliberately engineered defences built specifically to exploit terrain. And that turned out to be precisely the conditions under which the weapon's particular geometry mattered most. The Italian peninsula runs approximately 700 miles from north to south, and almost all of it's mountainous. The Apennine Range forms the peninsula's spine, with ridgelines and peaks running roughly parallel to both coasts. For Allied infantry advancing northward from September 1943 onward, every prepared German defensive position occupied naturally dominant ground, high, often rocky, with valleys and approach routes visible for miles. Kesselring structured the German defence of Italy around a succession of prepared lines that exploited this geography. The Winter Line in late 1943. The Gustav Line, anchored on Monte Cassino, a Benedictine monastery atop a massif visible for 30 miles, held Allied forces for 5 months. The Gothic Line, the last major defensive belt before the Alps, stretched 200 miles from La Spezia on the Ligurian coast across the Apennines to the Adriatic port of Pesaro. Each line was built into the mountains themselves. The National World War II Museum describes Gothic line construction in terms that capture the physical reality. Italian labourers, working under German supervision, dug fortifications with defensive positions etched directly into the Apennine rock, not piled against the mountains, cut from them. Stone walls, reinforced with timber and concrete, positioned at elevations that gave clear observation of every approach route below. The US Army's official campaign history, Cassino to the Alps, records what it cost to advance against these positions. From the September 1943 landings near Salerno to the German surrender in May 1945, 312,000 Allied soldiers were killed. The tactical key to all of it was the reverse slope. A reverse slope position places the defender on the slope facing away from the attacker, behind the crest of a ridge rather than on it. From the attacker's side, the position is invisible. The crest blocks the line of sight. Rifles can't range a target they can't see. Machine guns fire horizontally and are equally blocked. Tanks, which add direct fire guns and armour to the infantry attack, require line of sight to engage. Artillery, which can fire at a high angle and loft shells across a crest, operates on a timescale that disconnects it from the immediate crisis of a section already committed to its assault. On the reverse slope, the defenders are invisible and, for practical purposes during the first minutes of contact, unreachable. They fire down onto the approach route when the angle permits, observe all of the ground the attackers must cross, and wait. The Osprey analysis, beyond Rome to the Alps, confirms what Allied infantrymen learned in blood. The mountains and ridgelines of Italy provided optimal defensive positions at every stage of the campaign. The terrain was the defensive system. The fortifications were additions to ground that was already nearly impenetrable. Against a company of British infantry attacking up a ridge held by MG-42 crews on the reverse slope, no weapon in the conventional direct fire infantry could engage those positions from the forward face. The enemy was behind the hill. Artillery required time, The 3-inch mortar required a request chain. A high-arc mortar fired at 75 degrees sent its bomb up steeply enough to clear the crest and down steeply enough to land inside the position on the other side. The reference work Mortars in World War II captures the principle directly. The high arc of fire allows the projectiles to clear these obstacles. Every ridge in Italy that made an MG42 crew invisible to direct fire also made them geometrically reachable from a weapon that arced its bomb above 45 degrees. The reverse slope that was invisible and safe from everything firing horizontally was, to a weapon that fired overhead, a hole in the ground. The MG42 was the weapon that made German defensive positions in Italy so formidable, and its tactical logic reveals the specific vulnerability the 2-inch mortar exploited. The gun fired at approximately 1,200 rounds per minute, a rate so high that the individual shots blurred into a continuous tearing sound, unlike the staccato of conventional machine guns. British soldiers who had never heard it recognized it immediately in contact. The sound itself was tactically significant. It induced the instinctive freeze that any unexpected high rate of fire weapon produces, and communicated the lethality of the position to everyone within range. German machine gun doctrine built the defensive system around that lethality. Field regulations specified that the MG42 wasn't to be used for sustained fire if avoidable. Barrel overheating and ammunition expenditure were both prohibitive at 1,200 rounds per minute. Instead, guns were sighted to deliver short, concentrated bursts of enfilading or crossfire against specific approach routes, with interlocking arcs covering the ground between adjacent positions. Warfare History Network's documentation of Wehrmacht field tactics identifies 5 principles of German machine gun deployment: surprise, fire and movement, coordination, concentrated effect, and control. One gun covered the ground the next gun was sighted on. Attacking the gun on the left brought fire from the gun on the right. Attacking on the right brought fire from the left. And attacking frontally meant crossing the prepared kill zone of both. The killing ground in front of an MG42 position had been cleared, measured, ranged, and marked. Every piece of cover removed, every approach angle considered, every distance known. The crews were expert at what they did, and what they did was horizontal. Clearing ground in front of their positions, establishing fields of fire that dominated the earth approaching them. Standard 2-man slit trenches and MG emplacements provided solid protection against direct fire from the front and flanks. Overhead cover, where it existed, was a deliberate addition to standard positions, built when time and materials permitted. Even when overhead cover had been constructed, mortar bombs had been specifically engineered with delay impact fuses to penetrate it. Detonation was delayed until the bomb had passed through whatever cover it struck, so the explosion occurred inside. The more perfectly a German position had been prepared to its own doctrine, fields of fire cleared, arcs interlocked, positioned on the reverse slope, the more completely it had oriented its defences toward the horizontal threat. Every sandbag, every cleared metre, every reinforced firing parapet pointed toward the valley the attackers were coming up. None of it pointed upward. On 31st August 1944, Lieutenant G.R. Norton of the 1st Battalion, 4th Hampshire Regiment, led a platoon attack on the Gothic Line strongpoint at Monte Gridolfo. Elements of the 26th Panzer Division had occupied the position only hours before the British arrived. Norton's men were pinned by fire from concrete bunkers on their right flank. The 4th Hampshire regimental history records what followed. Norton went forward alone and attacked the 1st MG position with a grenade, killing the crew of 3. He then moved to a second position containing 2 machine guns and 15 riflemen, fought for 10 minutes under direct fire from an enemy self-propelled gun, cleared both guns, was wounded, and continued leading the platoon through the remaining positions. He received the Victoria Cross. Norton solved, through extraordinary individual heroism, the tactical problem every British platoon in Italy faced dozens of times. A position immune to direct fire from the front, requiring close-quarter action to neutralise. The 2-inch mortar existed to provide a more sustainable answer to that same problem, one that didn't require a single man to absorb all of its cost. The tactical logic explains why the weapon worked. Understanding what it felt like to be on the receiving end requires a different kind of analysis. Infantry under artillery fire develop, through experience and repetition, a set of survival responses that are partly instinctive and partly trained. The distant crack of a battery firing, the rushing, building sound of an incoming shell, the particular quality of a round aimed close rather than a round passing overhead. The direction of incoming fire can often be estimated from the sound, velocity, angle, the Doppler shift of approach. The standard responses, pressing into the earth at the base of a trench wall, choosing the most protected corner of a shell crater, identifying the gun line and lying perpendicular to it, were genuine, effective survival calculations. Fear under artillery was enormous. It was also fear with a rational structure. You could act on it. Close-range mortar fire removed the rational structure. The 2-inch mortar's muzzle velocity was 180 to 210 meters per second. A standard field gun propels its round at 700 to 900 meters per second, 4 to 5 times faster. That velocity differential is also a force differential, and force differential translates directly into acoustic energy at discharge. The 2-inch mortar's small propellant charge, firing at low velocity, produced a discharge substantially quieter than any conventional artillery piece of comparable battlefield presence. At 200 meters, a practical, commonly used combat range in the confined terrain of Italian valleys and bocage hedgerows, the bomb left the muzzle and arrived at its target in under 3 seconds. 3 seconds is insufficient time to identify an unfamiliar sound, locate its direction, recognize it as a threat, and initiate a physical response, particularly when the surrounding soundscape already included Bren gunfire, shouted orders, and the noise of an ongoing firefight. A second New Zealand Division account of the Italian campaign, preserved in academic archives at Massey University and drawn upon in subsequent infantry analysis, describes the experience from the receiving end. Crunching bursts of incoming mortar shells sounded clearly. The impact, not the launch. The bomb arrived before the sound of its departure could be registered as information about its approach. The first warning was the explosion itself. This is the element that separated close-range mortar fire psychologically from artillery. Under artillery, the incoming sound gave time to act. 10 seconds, 20 seconds, sometimes more. Under the 2-inch mortar at short range, the available interval between a detectable cue and impact was near zero. A soldier in a slit trench who heard nothing identifiable as incoming had no vector to orient toward, no direction to press away from, no corner of his position provably safer than where he already stood. The bomb arrived from overhead. The standard defensive instinct: press lower, press into the earth, interpose cover between yourself and the incoming round, was counterproductive. A man pressing into the base of his slit trench was pressing into the geometry the bomb was approaching. Every horizontal threat instinct, identify direction, use prepared cover, didn't apply to a weapon firing at 75 degrees of elevation from 200 meters away. The prepared cover faced the wrong direction. The trench walls that stopped bullets stopped nothing descending from above. What this created in the men subjected to it was a particular kind of helplessness, not the fear of a known, ranged threat, which is terrible but navigable, but the fear of a threat that couldn't be located, anticipated, or defended against by any action of your own. German defensive positions in Italy had been built with considerable labour and engineering skill to make their occupants invulnerable to everything approaching horizontally. The 2-inch mortar attacked from the one dimension those positions had no answer to, in seconds, without announcement. Academic study of combat psychiatric casualties in the Normandy campaign, published in the Cambridge University Press Journal series and drawing on frontline medical records, identified mortar fire as a primary cause of psychological breakdown in close country fighting. The pattern in Normandy matches what the Italian campaign evidence describes: the unpredictability of the weapon's arrival, the impossibility of defensive action, and the sustained nature of the threat. A weapon that could be back in action within a minute, fired from any position the attacking platoon happened to occupy, collectively produced effects that went beyond physical casualties. Analysis of secretly recorded conversations among German prisoners of war held in British and American facilities during the war, and later compiled by historians Zonka Neitzel and Harold Welzer in their study Soldaten, documents Allied fire as a persistent and central feature of German soldiers' inner experience throughout the European theatre. The transcripts show soldiers returning repeatedly, in private conversation with fellow prisoners, to the experience of being under close-range fire from above, from the immediate, intimate weapons of the infantry already in contact with them. Specific attribution, isolating the 2-inch mortar individually, distinct from other short-range mortars, is difficult to establish cleanly from the surviving records. The testimony shows consistently that plunging fire from infantry-level weapons, arriving without adequate warning into positions constructed against every horizontal threat, produced fear qualitatively different from the fear of artillery or tank fire. German soldiers' own defensive preparations confirm the threat as clearly as their testimony. Photographs from the Eastern Front, taken as early as July 1942, show German infantrymen constructing improvised overhead covers for foxholes against mortar fire specifically. Not rifle fire, not artillery, mortar fire. The overhead bomb that reached into the vertical space that standard slit trench preparation left undefended. Artillery cover required more substantial engineering than two soldiers could improvise in a forward position. Mortar cover was something a pair of men built with timber and sandbags because the threat arrived from directly above and the need was immediate. In Italy, where positions were cut into rock rather than scraped from steppe soil, improvised overhead cover was significantly harder to construct. The mountains that made defensive positions so formidable made them difficult to improve against the vertical threat. An MG-42 crew in a stone-reinforced position on a reverse slope in the Apennines had hardened every approach angle their doctrine anticipated. They had solved, to a considerable degree of engineering quality, every threat they could identify. They had not solved a 10.5-pound tube already in the platoon attacking them. What happened at the Gothic Line in September 1944 captures both the quality of German defensive preparation and its limits against overhead fire. The Gothic Line had been built using conscripted Italian labour under German supervision across months of construction. Stretching 200 miles across the Apennines from the Ligurian coast to the Adriatic, it incorporated reinforced concrete machine gun posts, anti-tank ditches, artillery positions and wire obstacles, with the Apennine ridgeline itself forming the backbone. Kesselring had not expected to need it. He had fought the Allied advance up the boot of Italy so effectively that for months the Gothic Line felt like strategic overkill. By the summer of 1944, with Allied forces pushing north after breaking the Gustav Line, it was very much needed. On August 25, 1944, the British 8th Army renewed its offensive with 5th Corps and the 1st Canadian Corps advancing across the Metre River. The advance netted 4,000 prisoners in the opening days. The Coriano Ridge held against initial assault for more than 3 days. Heavy rain on September 3rd flooded the terrain and slowed momentum. But the pressure across the central Apennines, particularly the Fifth Army's assault through Il Giogo Pass, cracked the line at multiple points. 2 battalions of the American 363rd Infantry Regiment began the ascent of Monticelli on September 13th, encountering heavy mortar and small arms fire from prepared positions. One company was stopped by German artillery. Officers and volunteers crawled forward under fire to locate it. Accurate 155mm counter-battery fire silenced it the following day. When the company moved forward and captured 5 dazed Germans, they had achieved the first penetration of the Gothic Line's centre. The elite Fallschirmjäger, German airborne infantry, among the most capable soldiers in the Wehrmacht, launched violent counterattacks against the breach. Private First Class Oscar Johnson, an American mortar crewman who had expended all his rounds, collected weapons from fallen comrades and held his position through the night of September 16th to 17th. His Medal of Honor citation records that 25 German soldiers surrendered to him in the morning. 150 German dead lay in front of his company's position. On the night of September 17th, General Joachim von Lemelsen directed the 1st Parachute Corps to vacate the Gothic Line. Futa Pass was given up simultaneously. Kesselring's diary, written in the immediate aftermath, recorded the weight of 2 years of Italian campaign. That the whole defensive system felt like it was beginning to slide. The Fallschirmjäger had not lacked courage or training. Their positions had been prepared with considerable skill and held the features that German defensive doctrine specified as optimal. What they couldn't do, repeatedly and across the entire defensive front, was keep bombs from arriving overhead. The bocage of Normandy gave the same weapon its second major test in terrain that reproduced the Italian problem at a completely different scale. The Norman hedgerow country covered most of the ground immediately inland from the D-Day beaches. Hedgerows in this region were earthen banks, often 2 meters high, topped with dense interwoven branches that had been growing for centuries. The banks were rooted into the soil and as solid as a field fortification. They divided the Norman countryside into small, irregular compartments, rarely more than 50 to 100 meters across, with each field presenting its own contained tactical problem. Sight lines were measured in meters. From the floor of one field, the far end was invisible. The hedgerow on the opposite side was opaque. This geography was ideal for a defensive force. German MG positions established in hedgerow corners, where the crossing of 2 earthen banks created a natural pillbox with fire covering both adjacent fields, dominated every approach route at point-blank range. The D-Day assault training records note that British infantry spent specific time on 2-inch mortar practice at Slapton Sands before the Normandy landings, indicating that British planners anticipated exactly the close-range, indirect firework that the bocage would demand. British Second Army carried the standard platoon establishment into Normandy on June 6, 1944. 1 2-inch mortar per platoon headquarters, moving with the men who needed it. The Osprey volume, Stout Hearts, British and Canadians in Normandy 1944, confirms deployment throughout the campaign. The operational records of specific engagements are concrete. Fields of War, Battle of Normandy, records one outcome directly. An accurately placed 2-inch mortar round silenced the German machine gun position. The history of the 50th Northumbrian Division in Monty's Northern Legions describes a section commander who mounted a 2-inch mortar and sent bomb after bomb to fall on the enemy position. These are documented instances of a standard tactical response, repeated across hundreds of actions in the hedgerow country from June to August 1944. The US Army War College paper, Busting the Bocage, confirms the broader pattern. In the Norman hedgerows, mortar fire was particularly effective, causing as high a proportion of casualties as any weapon. In field after field, the weapon that fired at the steepest angle reached positions that everything else was blocked from reaching, and it reached them from the hands of the men already in the firefight. The terrain was different from Italy, rolling Norman farmland rather than Apennine rock, hedgerow earthworks rather than ridgeline crests. The physics were identical. A steep arc bomb clears whatever the tube is pointed over and arrives from above whatever is behind it. The problem the Italian campaign had identified, a prepared defensive position immune to direct fire, was reproduced in miniature in every Norman field. The answer was the same 21-inch tube, held at angle by 2 men already in the fight. The weapon remained in British Army service until the late 1980s, replaced eventually by the Royal Ordnance 51mm infantry mortar. The longevity tells you something the specifications alone don't. You don't retain a weapon for nearly 50 years because it was available and cheap. You retain it because the tactical problem it was designed to solve turns out to be durable. That problem, infantry on the attack, in contact, being held by a position they can't engage with any weapon that fires horizontally, needing fire support in seconds rather than minutes, isn't specific to Italy or Normandy. It recurs in every terrain where prepared defensive positions can exploit elevation or concealment. The British Army recognised by 1938 that solving it at the platoon level was more reliable than solving it through the request chains that connected rifle sections to battalion fire control. The 2-inch mortar was the instrument they built toward that recognition. Kesselring's engineers did everything that defensive engineering could do in Italy. They cut fortifications into Apennine rock. They positioned machine guns on reverse slopes behind crests that blocked every direct fire weapon in the Allied infantry. They established interlocking fields of fire that made each position dependent on and protective of the ones beside it. They built the most formidable static defensive system of the campaign against every threat they could identify. The 2-inch mortar attacked from the one angle they hadn't solved. A 10.5-pound tube, a 21-inch barrel too short for the standard firing mechanism, requiring an engineering workaround to function. Sights removed because the men operating it had learned to aim by feel. A trigger mechanism bolted to the breech because the barrel was too short to work any other way. Every apparent flaw pointing to the same set of design choices. Be light enough to carry into contact. Be compact enough to fire in the seconds available. Fire at the angles that conventional weapons couldn't reach. British platoon commanders had something worth more than the precision those stripped-away sights might have offered. A weapon present in the fight, operational in seconds, arcing its bomb over whatever cover the enemy was hiding behind, arriving from the direction that none of the defensive preparation had addressed. The 2-inch mortar was never a precision weapon, and the men who used it never claimed otherwise. It was lethal in the geometrical sense, a firing arc between 45 and 90 degrees, aimed by hands and experience, delivering a bomb over crests that horizontal defensive doctrine had treated as impenetrable shields. The MG-42 crew that had done everything their training required, built their position correctly, cleared their fields of fire, established their interlocking arcs, chosen the reverse slope that made them invisible to direct fire, was still vulnerable to a bomb that came from above. The more carefully the position had been prepared, the more completely it had focused its preparation on the horizontal threat. The overhead angle remained unaddressed. The 2-inch mortar covered it absolutely. Veterans who operated the weapon remembered the physical technique decades after leaving the army. They remembered where the hands went, how the tube felt at the correct elevation angle, how to read the fall of the first round and adjust the second. That retention of physical memory is the signature of a skill used repeatedly, under pressure, in situations where the technique was genuinely consequential, where firing correctly meant your section could move, and firing wrong meant they couldn't. German engineers built some of the most sophisticated static defensive systems of the war. A British private carrying a 10-pound tube and holding it at the right angle by feel, firing by trigger squeeze rather than by dropping a round, aiming without sights by instinct acquired over hundreds of rounds, gave his platoon the one answer those defences had no counter for: immediacy, portability, a trajectory steep enough to reach behind any crest, over any hedgerow bank, into any reverse slope position that horizontal doctrine had declared impregnable. The machine gun crew behind the Winterline Ridge had done everything correctly. The geometry of the hill made them invulnerable to everything that fired horizontally. The 10.5-pound tube 200 meters away made them vulnerable to everything that didn't. Subscribe for more stories like this.